Okay, substitution rule for integrals. Let's open up with that. All right. Okay, so first I'm going to use u substitution. So I'm going to let u equal 10x squared plus x to the 5 minus 2. Then I'm going to take differentials. So du equals 20x plus 5x to the 4 dx or in other words, a fifth of du is equal to 4x plus x to the 4 dx. Now here it's saying x equals 0 and x equals 1, right? So if x is equal to 0, then u, if I just plug it in, is equal to -2. And if x is equal to 1, again, if I just plug it in, is equal to 10 plus 1 minus 2, so 9. So I think that the integral is now 3/5, and this piece here and the dx are du, and that piece there is just literally u to the 6. So I'm going to bring that closer actually. And then these limits are -2 and 9. And then, then what? Well, then you evaluate and you do substitution, don't you? So it's 1/7 of u to the 7, -2, 9, right? And let's try it out. Okay. So first I plug in 9. 1/7 times 9 to the 7. Okay, I'll do the subtraction actually. And then take away 1/7 times -2 to the 7. And all of that is that. So using that there, I get this. Don't know if it's right, don't know if it's wrong, but I'm going to try. 490,979.7429. All right. Now let's see what the actual answer is and see how I did. Okay. Okay, so they're doing this nonsense again, where they're giving it in this one, 4, 3, 4, 9, 2, 9, 1. Okay, so that turns out to be okay. All right. Now I'm going to try this one. So, what's the substitution that I'm going to make? Well, I'll let u equal 9 minus 5 sine of 2t. Then du equals minus 10 cosine of 2t dt. So, but I want it to say 8 cosine of 2t. So what I'm going to do is divide it by minus 10 and then times it by 8. Just like that. Yeah. Now I have that piece there, which is going to replace that piece right there. Now, here, this is secretly saying t equals 0 and t equals pi over 4. Now, when t is equal to 0, if I look up here and I just plug in 0, well, sine of 0 is just 0, right? And therefore, u equals 9. And if t is equal to pi over 4, well, I come up here and I put in pi over 4. So that's pi over 2, which is 90 degrees, if you like. And sine of 90 degrees is 1. And so 9 take 5 is 4. Like that. So, might be in trouble here because it appears that things aren't the right way around, right? Well, we'll see. Now the integral will be 9 down here at the bottom and 4 up here at the top. And minus 8/10 of du. So like put that out there. Minus 8/10. Put that there. Put that there. And put that there. Just like that. And then do the integration. So minus 8/10. Then open up some square brackets here. Now this is u to the minus half. So you add 1 to the power, make it a half, and then divide by that. So 2. So 2u to the half, or 2 root 2. 2 root u, if you like. And then put 9 down there and a 4 up there. And open up some brackets here, put in 4. So what's 2 times root 4, the square root of 4? Well, that would just be 4. And then what's 2 times the square root of 9? Well, that would be 6. And so take away 6. And that's -2. And the -2 is being multiplied by that right there. And what we get as a result is 8/5, which is 1.6. But now we have to check the real answer. Oh, yay. That's great. And here's the notation you can do if you want. I was raised on this one, but it's totally fine. Third one. Now, if we, how are we going to do this? Now, if I let u equal 3 cosine of z, then du is equal to that. And this minus sign can come over here like that. Just move everything over so it looks nice. And then now this will just become u cubed du. Or will it? No, there'll be a minus sign in front actually. So remember this says z equals pi, z equals 0. Now, if z equals pi, what does that mean? According to this up here, that means, well, it's cosine of pi, which is -1. And if z is equal to 0, then it's cosine of 0, which is 1. So now the integral becomes, I'm going to put -1 down here, a 1 up here, and I'll put my minus sign and du right there. And then instead of this here, I'm going to put u cubed, just there like that. Minus sign, do the integration. So 1/4 of u to the 4, and go from -1 to 1. And what actually is that? So minus sign, open up some brackets, put in 1, so we'll get 1/4. Subtract, and I'll put in -1, we'll get 1/4 as well. And so we end up with 0. And that's great, just great. Fourth one. So what are we going to do in this case? Okay, let u equal 1 minus root w cubed, then du, well, that there is that. So well, that's no good. Oh no, it actually is. Beg your pardon. So minus 3 over 2 w to the half. So we get this just there like that. And dw, but we want it as root w dw. So multiply both sides by negative 2/3. Just there like that. Now, if w is equal to 1, this is the lower limit of the integral. If w is equal to 1, then u is equal to 1 minus root 1, so u, so 0. And if w is equal to 4, then u is equal to 1 minus the square root of 4 cubed. 4 cubed is 64, so that becomes 8. And 1 minus 8 is minus 7. So we can rewrite the integral now as, let's put minus 2/3 and du there. Let's put 0 and minus 7 there. And let's put e to the u there as my integrand in the middle. So minus 2/3, we do the integration, we get e to the u, put 0 there, minus 7 there, and then do the computation. E to the minus 7, and that would be minus 1. Which is about this. And we must check. And that's right. And that's good. Fifth one. All right, so what are we going to have for our substitution? Let u equal 5 minus 2y. Then du is just simply minus 2 dy. So minus a half du is equal to dy. Now, when y is equal to negative 4, pick up minus 4, put it in there. And this tells me that u is 13. Y is equal to negative 1. This tells me u is 7. So now we make the substitutions. So we're going to have minus half on the outside. 7, right? No. Careful. 13 there. 7 there. Cube root of u there. Plus 7 over u. And all of that is du. Alright, so we have minus a half. Now that's u to the 1/3. So you add, say, 4/3 of u to the 4/3. And this is 7u to the minus 1. So when you integrate, it'll become 7 ln of u. And that goes from 13 to 7. Okay, so just make the substitutions here. Alright, so minus a half and big brackets. And first plug in 7. And then plug in 13. And take that away. And then multiply all of that by negative a half. And then check. All right, so he has it in quote-unquote exact form here. So I guess we have to check and see if his matches our decimal approximation. So 13 to the 4/3. minus 7 to the 4/3, and then plus 7/2 times ln 13, take ln 7. And not quite, unfortunately. So where did this go wrong? If it did go wrong. All right, so I agree with that. Yes, that's fine. Oh, that should be 3/4, shouldn't it? I see. All right. Okay, and so that is more accurately 8.6079. Okay. And now the 6th one. So this is x cubed, which is something that we can definitely do. But in fact, we can actually do both of these, right? Nonetheless, we'll split it up. Like this. For integral a, we integrate x cubed, which is 1/4 of x to the 4. And do so from -1 to 2. So we plug in 2, so that'll be 16/4, which is 4. And then plug in -1, so that's just 1/4. So that'll be 3 3/4, or as some people like it, 15/4. For integral, I swear I'm just trying to remember, isn't it 1/4? I just always get these the wrong way around if I don't be careful about it. So you divide through by that term there, so it would actually be 4. 4, right? Four e to the quarter from -1 to 2. -1/4 x from -1 to 2. So 4 times e to the half, so 4 root e. And what's that? To the minus quarter. Okay. $3.47968. So I guess the total then is this, roughly 7.22968. But I don't doubt that he'll do it in exact form. Yeah, there we go. Right, so I have to check that. Well, actually, I mean, it kind of obviously matches if you just look. Yeah, so that's fine. Okay. For number 7, this is one that you can split. It's just a case of once and for all remembering what happens to the constants. That's true. I think it's this. So if I differentiate that, yes, that's true. All right. Okay, so I can do this. So we integrate from pi to 3 pi over 2 sine of 2w dw, and take away 7 pi to 3 pi over 2 cosine of w dw. So what? So 6 and this, and this, and all right, so we'll do 6 and open some brackets, and then we'll take away 7 and we'll open some brackets. Okay, so 2 times 3 pi over 2 is 3 pi. And what is cosine of 3 pi? Minus 1. Isn't it? And what is cosine of 2 pi? 1. And what is sine of 3 pi over 2? Minus 1. And what is sine of pi? Zero. It is 0. Okay, so evaluate. That's a half. And I'm taking away a half, so 0. And 6 times 0 is 0, so 0. It's minus 1, so plus 7. So I think it's just 7. Oh, darn it. Okay. That's true. Oh, no. Wait, no, wait. All right, so I could do substitution, but I want to see why this isn't right, if it isn't. Where did I go wrong? That's fine. Where is the error? It should be here, right? Because that's the 7 that they're looking for. So where is this one? It's here, isn't it? But I can't seem to see it. Because of some kind of blindness or something. Oh, I know. Look at that. Minus. And that should be a minus. That's actually a plus. Right? So that's a half plus a... No. No, that's absolutely fine. Okay, so that becomes a 6. And that becomes a 13. Cool. Okay, that's correct. All right. Problem 8. Okay, so I'll split it. This rational function here. Like that. Okay. 3. 5 to the 4. 3125 plus 253150 3151. Like that. And a half. And then 1 over u du. So okay. That's the first one. And the next one. The next one looks like this. So minus the integral from minus 3 to 21 of half, bring that out. One over u du, which is minus a half of ln u 21 negative 3. But perhaps this integral is not defined. Did you ever think about that? Maybe. I don't see 0 in the interval of integration, so it seems okay. But perhaps I'm wrong. First, he answers in exact form, doesn't he? So that should be fun. Look at that. I knew it. Or I half knew it. I half knew it. Got to check. Until I remember. For integrability. Okay. All right, problem 9. Problem 9. All right. It is not permissible for this to be 1/6, but that's actually okay, because it can't be 1/6 because it goes from -2 to 0. It goes from -2 to 0. So three plus the square of that. 3 plus that, so 3. All right. Oh my goodness. Wow. Negative 12, negative 1, so negative 13, and negative 1. And we'll say a half du twelve over 26. Please, please, please be accurate. Please be accurate. Oh, I hope this is accurate. Oh man, why does he have to? It's fine. It's just frustrating when he does this. Okay, it's not accurate. Why is it not accurate? That's fine right there. So did I just not evaluate that right? I mean, that's fine. I got that bit right. And the other bit is, yeah, and I got that bit right as well. So I just haven't plugged in things correctly. That's what it is. That's exactly what it is. It has to be that. How could it be anything but that? No, I'm going to leave the incorrect answer there. I want to check and see what's actually going on. So, it's 1/3 of, first, I shall plug in 3. So, 3 to the 3/2, 3 to the 1.5. Okay. Then I shall plug in 7. So 7 to the 1.5. I'll take them away. Got the same answer. Right, and then down here, do the exact same thing. I get minus 6/13. But doesn't that have to be taken away? Right, and so it's plus 6/13. So I still don't understand how it's not the right answer. All the pieces match up on the end. So, sorry, that one sort of baffles me a bit. For some reason, he's given all of these in exact form, even though beforehand he did approximations constantly. Don't know why I did that. Now, I sense this may be a trick. Maybe not. Don't know. So perhaps I'll just quickly nip to the bathroom. Yes, I'll just nip to the bathroom and then be right back. All right. Let's see. No, next one. Oh no. Didn't do my limits, did I? All right. Two minus minus 2. 2 minus minus 1. 44, that's 256. 256 over 4, 64. Probably he's not even going to evaluate that. Okay, now B, the next integral. This one here. So what am I going to do? Make U be that bit. Oh no! Look at that! I copy that down as -1. No! Alright, okay. I have to do this. I have to fix this. Because if you don't fix it, then it will be wrong. Right, so put in 1 there. So 2 minus 1 is 1. So it should be a 1. Now, where would that cause error? There. And there. And there. And of course, there. And there. Okay, so yeah. 1 goes there. And there. And now plug in 1. So a quarter. And a quarter minus 64. And then the negative version of that. 63 3/4. Okay. Okay. All right. Sine of pi z, chimpanzee, times 3 plus 2 cosine of pi z. Let u equal 3 plus 2 cosine of pi z. Then du equals what's the derivative of that? Minus so I believe it should be that. So minus 1 over 2 pi du is equal to sine of pi z dz. Now, if z is equal to negative 2, what does that mean u is equal to? That thing there, which I should be able to do mentally. You have to push against the urge to be lazy. Minus 2 pi cosine of minus 2 pi is 1. And then it's 2 times that. So 2, and then add 3, so 5. So I believe and z is equal to 1. Okay. Cosine of pi is negative 1. So it's negative 2. 3 minus 2 is 1. So I should say 5, 1, just there like that. And we'll bring the minus 1 over 2 pi outside. The du goes right there. And let's cube u just there like that. Minus 1 over 2 pi there like that. Open some brackets now. Integrate u cubed. Okay, that's a fourth of u to the 4. And go from 5 to 1. All right. So first, we'll put in 1. So that's just going to be a quarter, simply a quarter. Then we're going to put in 5. So that's 3, 1, 2, 5 over 4. And all of that we're going to multiply by minus 1 over 2 pi. And we get something incredibly close to an integer, which is spooky. Isn't that weird? And let me guess. He's going to answer in exact form. He's not going to do a decimal, is he? Nope. For no reason at all. So let's just sort of comply with that and let's figure it out. 63 times 4. Well, that would be this would be 255 over 4, right? Okay, so I think that's correct. Now, we have minus 781 from this, and times that by 1 over 2 pi. Like that. That's what we got. But is it right? Of course not. Do you know why? Because it's not 3125 Liminek. 525, 125, 625. I keep forgetting that that's the correct power of 5. And when I do that now, I get the 156. And that has to be divided by 2. And then you get the 78, which is what we're after. Right, so that's fine. But correct the error. Correct the error. So where is the error? Where is the error? Oh, it's not actually on the page. It's in the air. Now it's disappeared. Okay, so that was substitution rule for integrals. Oh no. Is this like a continuation or something? I didn't do this yesterday. Oh, right, for definite integrals. All right. And I'll say that. Now, on to something new. L'Hopital's rule. Not working. Okay, so just try your best. Just try your best. Now, if you just put in 2, then it doesn't work. And from what I can remember, this rule says as long as you can differentiate the top and the bottom, you just do that and it'll evaluate to the same thing. Or so I think. This is just what I remember, so I need to check. And that you can actually get, right? And again, this is why you can't actually just plug in -4. So now cosine of -4 pi is 1, so it should be pi over -8. So I believe it's that. We'll soon see. We'll soon see. Cool. All right. Darn it. So you integrate the top and the bottom. All right. Sorry, differentiate the top and the bottom. All right. So I think. I think that's just 0. Oh, right. The site might be getting stuck. Oh, no. Can't believe I made such a basic blunder. Is that? Right, the fourth one. Can't plug in 0. I'm just going to expand that on the bottom. Yeah, okay. So z squared r 2, z squared r 2, z add 1. By L'Hopital's rule, the limit is z approaches 0. Okay, so that'll be 14 over 2, which is 7. I believe it goes to 7. Check that out. I did it. Very happy about that. And now that you're comfortable, time to make you completely uncomfortable. It's always the way, isn't it? Minus infinity. Here comes the part where I don't remember how to actually do this. But just try some things, and who knows? Who knows? minus x minus e to the 1 minus x. Now, this isn't going to work because you're just going to keep on plugging in that. However, if I do keep going, notice that. Now we have 2 divided by a very, very small number. So it's infinity, isn't it? I think so. I think that shoots off to infinity, doesn't it? No, totally wrong. All right, try to understand why. Like, couldn't, like, wait a minute, wait. Was I just thinking of it wrong? Let's see. That would be e to the million, e to the million trillion, super huge number. So yes, it was just a blunder. That's all. Not a fundamental wrong understanding. Okay, but I'm just waiting for that moment to come when you know, I'm just shown to be colossally wrong for reasons that I don't get. And that's good. So, differentiating now on the top and the bottom. First, yes, okay. So 2z plus 4e to the 4z all over 2 minus e to the z. Now, still not defined. Okay, still indeterminate form. Still indeterminate form. That over that, and then that's what is that? It's that, isn't it? And that shoots off to the moon. Right? Or am I not right? Negative infinity. Must remember the negative sign. Must remember the negative sign. Right. Try again. Okay. Now, this is not a quotient, is it? No. But you can make it into a quotient. Because you can say that it's this. Right? And so what we have to do is now differentiate on the top and the bottom. Hold on just a minute now. Hold on just a minute. That will be the natural logarithm of 1. And to what power must e be raised to get 1? The answer is 0. So that's undefined. Okay, I get it. All right. So differentiate on the top and the bottom. One. Okay. What happens when you differentiate this, though? F prime g minus f g prime all over g squared. So f prime g minus f g prime. Differentiate that. Hello. Okay, I think it's 3 over 1 add. No. No, totally wrong. Try again. Okay. The bottom is 1 plus 3 over t. That's correct. Now differentiate the inside. Okay, 3t to the minus 1 becomes negative 3t to the minus 2. Now, the square of this, isn't that right? Oh my goodness me. So it's all of that, and so all of this has to be flipped over, right? There. And all of that has to be flipped over, I think. T goes to infinity of this, ln of 1 add 3 over t. All of that has to be squared, and divide all of that by that minus that. And do you know what this is? Do you know what this is? No, I don't. So minus 3 over t squared. One plus 3 over t is t over t plus 3 over t, which is t add 3 over t. T add 3 over t. T add 3 over t. So it becomes that. Right? minus 3t over t cubed add 3t squared. No, that's fine. Right, ln of 1 add 3 over t. This is such a mess. There's no way that this is the right answer. Cancel off some t's there, yeah? Minus 3 over t squared add 3t. Oh, man. So that's 0. And that itself is 0. 0 minus 0. It's just... Please, if he says differentiate it like twice or something, I'm not going past that. There's no way. Okay. Right, so first of all, you got this wrong. Okay, all right, so I got that wrong. Okay. Just work from that point there, at the very least. Do not just mindlessly copy. Try to understand what happened. Yes, I understand that. All right. Then we get this, and so this, although I cannot evaluate it yet, I can apply L'Hopital's rule. The limit as t approaches infinity of differentiate that, we get that's 3t to the minus 1, so it becomes minus 3t to the minus 2, so minus 3t to the minus 2 all over 1 add 3t to the minus 1. Okay, and that has to be over the derivative of that. D by dx of 1 over x, d by dx of t to the minus 1. T to the minus 2. Done it a million times now, but it's confusing me with the integration. Minus t to the minus 2. There you go. All right. Now, simplify the algebra. So that there is divided by that there. And that means that you multiply the bottom by that there. So minus 3t to the minus 2 over minus t to the minus 2 minus 3t to the minus 3, like that. Like that. Yes. I think that's 3. Yes. All right. But notice how efficient that is to do that. All right. Okay, good. I understand that now. That's better. If you have a piece of fruit. Say it like that, without any speech marks or weird or symbols. Anyway, be well.